out there. I am Tanya Verma. Today, me, along with my group mates Haley Lalakia, Joseph Jackson Paul, and Vinay Chilamula, have got a golden opportunity to discuss the topic thin layer chromatography. We, the group members of Group 8, are very thankful to our respected ma'am to deemed us to fit to do this work. So let's begin. Before we proceed further, we should know what is chromatography. Chromatography is a lab technique that allows the separation, purification, and identification of the constituents of a mixture for purpose of qualitative and quantitative analysis. Chromatography may be preparative and analytical. Preparative chromatography is used to separate components for later uses. However, analytical is done for measuring the relative proportions of analytes in a mixture. Now let's talk about thin layer chromatography. The thin layer chromatography, or the abbreviated form as TLC. It is an affinity based technique used to separate or isolate non-volatile mixtures into its constituents using adsorbent spread over a plate and liquid as a mobile phase. This is one of the widely used techniques for both qualitative and quantitative sample analysis, as it is highly versatile, sensitive, and cheaper as well. TLC is a form of liquid chromatography and involves two phases. The first phase is mobile phase and the second phase is stationary phase. The analysis is done under atmospheric pressure and room temperature. This method involves performing several steps including preparation of developing container, preparation of TLC plate, spot the TLC plate, visualization of spots, and some more. For this method to be performed, a sheet of an inert substrate is required like aluminum foil, glass, plastic, needed to be coated with adsorbent material might be silica gel or cellulose. Separation of compounds is based on the contrast of solute and mobile phase of binding site on the stationary phase. On completion of isolation, each component appears as vertically separated spots. In order to visualize the spots, UV light is projected onto the sheets that are treated with a phosphor like zinc sulfide, and dark spots appear on the sheet where compounds absorb the light collides on a certain area. Each spot holds a retention or retardation factor which can be calculated mathematically. This method can be used to monitor progress of any reaction, identification of compounds present in a given mixture, and also in determining the purity of substance.
Now, let's discuss about the principles and procedures of the thin layer chromatography. The separation principle of the TLC procedure is based on the given compound's relative affinity towards the mobile and stationary phase. The process begins here by moving the mobile phase over the stationary phase's surface. During this movement, the higher affinity compounds gains less speed as compared to the lower affinity compounds. This results in their separation. Once the procedure gets completed, different spots can be found on the stationary phase at distinct levels, reflecting various elements of the mixture. Basically, the compounds that are more attracted towards the stationary phase secure their position at lower levels, while other moves towards the higher level of the surface. So, their spots can be seen accordingly. After the TLC principle, now let's move on to its procedure. Procedure of thin layer chromatography. From the information mentioned earlier, it must be clear that how TLC works. However, we still need to learn about its complete procedure to see its entire functioning. A few components involved in the TLC procedure are as follows. TLC plates. These are used for applying the thin layer of stationary phase. They are inert or stable in nature. The layer of stationary phase is kept even throughout these plates for better analysis. Usually, ready-to-use plates are preferred by the people conducting experiments. Mobile phase. This comprises a solvent or solvent mixture. The taken solvent needs to be chemically inert of the highest possible purity and particulate free. Only then can the TLC spots be able to develop. TLC chamber. This is where the thin layer chromatography procedure takes place. It keeps the dust particles away from the process and does not let the solvent evaporate. In order to develop the spots appropriately, a uniform environment is maintained inside the chamber. Filter paper. This gets placed inside the chamber after being moistened with the mobile phase solution. It ensures that the mobile phase rises uniformly throughout the TLC's plate's length. After collecting all these components, the process begins. Here are the steps followed in it. The process starts by making a thin mark on the TLC plate's bottom with a pencil. It helps in the application of sample spots. These spots are kept at equal distances. The sample is then applied to these spots made on the line. Then the TLC chamber is filled when the mobile phase up to a few centimeters of its bottom. After pouring the mobile phase, the moistened filter paper is placed along with the inside of the chamber wall. This helps to avoid edge effect by maintaining equal humidity. Finally, the prepared stationary phase plate is put inside the chamber. At this point, the sample spots are kept on the mobile phase. The chamber is then closed after placing the plate into it. Once enough time has elapsed for the process, the plate is taken out and allowed to dry. At last, the sample spots get analyzed through a suitable method for this sample, such as UV light, cheminophore stain, and iodine staining. This way, the TLC procedure gets completed. After analyzing the compound, it gets described in its relative mobility term. That is, its RF value is calculated. This value changes for each compound even under the same circumstances. Usually, relative RF comes into use here because keeping all the TLC factors constant may not be possible. These aspects include adsorbent temperature, adsorbent thickness, spotted materials amount, and solvent system. The formula used for RF value calculation is RF is equal to distance covered by the sample divided by distance covered by the solvent. Finally, let's explore about its drawbacks. Qualitative analysis and not quantitative analysis. Not an automatic process, the humidity and temperature can affect the result as a thin layer. Chromatography works in an open system. Separation process takes place only to a certain length as plate length is limited.
welcome to the channel solution. In this video, we will show you the procedure for preparation of TLC plates. TLC plates means thin layer chromatography plate of which one side is coated with adsorbent. The most common adsorbents are silica alumina. Here we have taken silica gel G as adsorbent. For the preparation of TLC plates, first we have to prepare slurry of silica gel G by mixing 1 part of the silica gel G with 2.5 part of distilled water. It means if you have taken 1 gram of silica gel G, then mix it with 2.5 ml of distilled water to prepare slurry. Here we have taken 5 gram of silica gel G into the glass mortar pestle and then add about 12.5 ml of distilled water and then mix it with the pestle to prepare slurry. Mix it properly to make sure that there are no lumps. Then after mixing, transfer the slurry into the clean dry beaker and by using glass rod make the slurry homogeneous. With the help of pipette, pour small amount of the slurry on the clean dry glass plate and then move the plate around to spread the slurry uniformly over the glass plate and to form thin uniform layer of adsorbent of about 0.2 to 0.3 mm thick. Make sure that there should not be any uneven spot on the plate and remove the excess slurry over the plate. Similarly, you can follow the same procedure to coat the big size glass plate with the slurry. These TLC plates can be used for analytical study. It is used to identify the components of a mixture and also to check the purity of the sample. Move the glass plate so that the slurry get uniformly coated over the glass plate. You can see that the slurry is uniformly coated over the glass plate. After uniformly coating the slurry, then dry these plates at room temperature. After drying the plate at room temperature, then finally place the dried plate in hot air oven for about 1 hour at 100 to 105 degrees Celsius to activate them. After 1 hour, remove the plate from the oven. Now our TLC plates are ready for analytical study. It is very important to note that always use forceps to handle the TLC plates. Do not touch the silica layer of the TLC plates as it can damage the layer and also cause contamination. You can also store these plates protected from the moisture and you can use this plate within 3 days. Make sure that at the time of use, activate the TLC plate again. Thank you for watching this video.
Hello everyone, I'm Vinay and my part of the topic is about pros, cons and applications of thin layer chromatography. Pros and cons of thin layer chromatography. Pros. It is a simple way to separate the components. There are fewer types of equipment needed in the procedure because the components elute quickly. The separation takes place only a few minutes. It is possible to view all the UV light components. This approach can be used to separate non-volatile substances. TLC may also separate microliter quantities of material. Complex mixes constitutes are easily separated and recovered. Cons. The experiment results are difficult to duplicate. Only applies to soluble combination components. It is qualitative research, not quantitative research. This isn't a straightforward procedure. Because thin layer chromatography is an open system, humidity and temperature can have an impact on the findings. Because plate length is restricted, the separation process can be confined to a specific length. Applications of thin layer chromatography. Pharmaceuticals, clinical diagnostics, environmental toxicity, food, water, pesticide analysis, and cosmetics are just a few sectors and research disciplines that employ TLC. TLC is used in a variety of ways. To find the purity of any sample. Purity of a sample can be carried out with TLC. Direct comparison is done between the sample and the standard or authentic sample. If any impurity is detected, then it shows extra spots and this can be detected easily. Identification of compounds. Thin layer chromatography can be employed in purification, isolation and identification of natural products like A volatile oil or essential oil, fixed oil, waxes, alkaloids, glycosides, steroids, etc. Biochemical analysis. TLC is extremely useful in the isolation or suppression of biochemical metabolites or constitutes from its body fluids, body plasma, serum, urine, etc. In chemistry, TLC methodology is increasingly used in chemistry for the separation and identification of the compounds that are closely related to each other. It is also used for the identification of cations and anions in inorganic chemistry. In pharmaceutical industries, various pharmacopoeias have adopted TLC method for detection of impurities in pharmacopoeial chemicals. Various medicines like hypnotic sedators, tranquilizers, antihistamines, analgesics, local anesthetics, steroids have been tested qualitatively by TLC method. One of the most important applications of TLC is in suppression of multi-component pharmaceutical formulations. This is the end of my part. Thank you.
And thus we come to the end of our topic of thin line chromatography. Just as a background check, this topic taught us about chromatography and especially about thin line chromatography. The definition and introduction were well defined by Tanya Verma. The principles and procedures were well explained by Heli Lalakia, and the pros and cons were brought to you by Vinay Chidamula. I, Joseph Jackson Paul, on behalf of all my teammates, would like to thank Elisa ma'am for giving us this opportunity and letting us bring this topic up and explaining it. I hope that the video was informative and it was brought to you by the collective efforts of all my teammates. And I would like to take this opportunity to thank every one of my teammates who put in the effort to make this video possible. I hope that everyone who saw the video understood what the topic was and they enjoyed the video. Thank you for watching.